some of these concept builders get pretty tough, especially this guy here. This is causing people some problems, so I'm glad to try to help you out. Okay, what you're trying to find out here is the current through each of these different paths. But you got to understand that if you are talking about a parallel circuit, it has multiple paths, so you don't just add them up. It's not that easy. So what we've got is a situation here. Let's write down what we do know. We know the voltage is 12 volts, and that's going to be the same everywhere up here. 12 volts, stop at that guy. 12 volts, stop at each of those resistors. 0 down here at each place. That's the same jump for each resistor. All right, resistor 2 has 3 ohms of resistance. And through A, there are 13 amps at position A. All right, so what that means is with this 12-volt battery pushing on these wires, on the electrons pushing off of each other within these wires, there are 13 amps worth of current flowing. Now they're going to split up. Some of it's going to go down this first path. So let's get on this a little bit better. So we're going to have some flowing that's going to come down the first path. Some is going to flow and go down the second path. Some will flow and go down the third path. But at point A, all 3 of the amounts of current are there, adding up to a total of 13 amps. I'm going to split up. All right, so what we do know is at position D, over here, there's 3 amps of flowing. So, what else do we know about this situation? Well, right here, we know that there's 12 volts dropping across it because it's in parallel. They all have 12 volts. 3 amps is flowing. And if we know those things, we can find the resistance. This is going to be V over I. It's going to be 12 over 3. 12 volts over 3 amps. And you're going to have 4 ohms of resistance. Hey, you know what? They're not even asking me that, but I just couldn't help but find it because it's laid right out there. Anyhow, so we know that's happening. 3 volts going around, 3 amps going around. All right, current in B. Let me think. We've got 12 volts going across it. We don't know the amps through there or the resistance. All right, what do we know in C? Well, we know for C there's 12 volts. 12 volts, and there's, oh yeah, there's 3 ohms of resistance. I told us that earlier. Right there, no, right there. So therefore we know then, if we know the voltage and the resistance, we can find the current, which is V. So that's 3, that's 4 amps flowing. Okay, so we know there's 4 amps at position C. So, 4 amps, we know that. Hey, wait a minute, we know it all has to add up to 13, right? Because you've got 3 that come flowing through here. You've got apparently 4 amps that are flowing. 4 amps that are flowing through the second branch. And if 3 and 4 are 7, then this last one over here must be 6 amps flowing. And you can check that if you wanted to find out what the resistance is, but it's not asking us that. So what's the flow at point E here? Isn't it just 13? Because wasn't 13 getting pushed out? Well, remember, there are 3 kind of groups of current, you could say. It has to add up to those 13. 6 of them weren't there yet. Only these 4 amps and these 3 amps were there, so at here, it's just 7 amps. Okay, I hope that was helpful and not too talkative. Good luck. Let me know if you want more. Okay, so check it out. So I've used the PhET simulation, the circuit construction kit, DC, to build that circuit we were just playing with. Got your 12 volt voltage source, 2 ohm resistor here, 3 ohm resistor there, 4 ohm resistor. So check it out. They all have the same push, the same voltage drop across each resistor. 12 volts here, which you see. Okay. Across this guy, also 12 volts. Across this guy, also 12 volts. You might say, well, wait a minute. That's no big deal. If I just put those 2 things anywhere, it should be 12 volts, right? Well, notice there's no difference in voltage here because there's the same amount of push through this entire conductive path. Same thing up here. If you put these 2 anywhere within the same conductive loop, it's just 0. Okay, what about the current? Does that check out like I said in the problem? This is nifty. This right there. Hey, 6, just like we calculated. Amps, that is. 4 amps in the middle, just like we calculated. 3 amps, like they told us. So check it out. Same voltage push across each of these resistors. But because this has low resistance, medium, and high resistance, you get different amounts of electron flow or charge flow. And by the way, this is the flow of electrons from negative to positive, but the conventional charge would be this. Notice how it's so much faster here and there than it is through each individual branch, because here it's all three of these currents added into one big fast flow, then they break down into separate currents or separate amounts. Okay, play with this, you guys. Why not? You got time on your hands.